Okay, hello. Today in this video we're going to cover density and pressure. I have videos that cover everything of these two topics in detail. So today we're only going to do exercises, but first of all I want to explain something, a little thing, okay? So when we finish this exercise, question 2, I'm going to explain the table we have on top, the blue things, okay? So these things here, I'm going to explain it to you now. So basically let's go to exercise 2 first, and then I'll explain it. So we have a piece of copper of a mass 435 grams has a volume of 48.19 centimeters cube. What is the density? Okay, so density is how much stuff or how much things is it in a meter cube. Okay, so how much mass is there in a meter cube? Okay, so the greater the mass, the more density there is. Okay, so for example in air, the density is so low that we can just go through it. Okay, because there's not a lot of air per volume per meter cube. Okay, so I have a video that explains everything, okay, about density and pressure, so you can go and watch it. So basically density is measured by kilos and meter cubes. Okay, kilos divided by meter cubes. The problem is here we're giving grams and centimeters cube. So how do we transform this? Okay, so that's where the table is. Okay, so let's say we have basically first of all you have to memorize this little table here. As you can see, there are two ones is for meters and the other one is for grams. But all I've done is change the G, like all the G's here for M's, and this applies for liters and other and different measurements. Okay, so this is kilometer, hectometer, decameter, meter, decimeter, centimeter, and millimeter. Okay, and this one will be gram, milligram, kilogram. I don't really know all the measurements, okay, like the names of them. But the thing is that it's a good table to remember. And why is that? Okay, because if we were to transform, let's say, 435 grams into kilograms, because this is the unit we have to use here, what we do is we put 435. See what I've done? 435, okay, and we want to reach kilograms, okay, so you put a 0 here and this is the kilograms, so the kilograms would be 0.435, okay, so that'll be that's an easy way to transform it. So we can say that the density is equal to 0.435, okay. I know I put a comma here, just kind of used to putting commas instead of dots, okay, divided by meters cube. How do we transform meters cube? Okay, that cube is really annoying because if it's meter square, meter cube, what we do is we're gonna do something similar, but it actually isn't. So what we do is, if we follow the other path, we'll say would be like this, the thing we did before. We would do this. We would do 48.19. Okay, I want to reach meters. Sorry, that's not right. We're given it in 48 centimeters. So it's 4.19, and the 9 is just there somewhere. That'd be nanometers, I think. Okay, so it doesn't really matter. So what we do, we just put a 0 here and we put a comma, but a dot. The problem is that's not right because that's meters cube. So any number that's cube or square or to the power of 4, what we do is here we did steps. Okay, so we did one step from grams to decograms, 2 steps, and 3 steps. Okay, so we did 3 steps to reach kilograms, for grams to kilograms, right? Here we have to multiply everything by 3, the number of steps. Okay, so here we have to go from centimeters to meters, so we're going to do 1 step and 2 step, okay, but because it's to the power of 3, okay, we have to multiply by the number of it, so it'll be multiplied by 3. If it's square, we'll multiply the number of steps by 2. If it's cube, we'll multiply the number of steps by 3. So then we would have to do, we did 2 steps, right? So we do 1. So let's do it again, okay? So we have to do 6 steps, right? Because it's 2 multiplied by 3 is 6 steps, okay? So we do 1, 2, let's put zeros all around here, okay? So we do 1, 2, 3, 4, 5, 6. So the dot, we put it here, okay? So bear that in mind. Now, this is going to be 0.00004819, and that one looks like a 6, so let's just redo it again. Okay, so because to this the meter cube, we have to multiply the number of steps by 3. Okay, if that's not clear, just rewatch the video again, because I think that's clear enough. So so now that we have that, right, we get the calculator. So let's get the calculator, and we do 0.435 divided by 0.1234819, and we get that the density of copper is equal to 902.677. Okay, so that's the density of copper. Okay, so we call it kilograms per meter cube. Okay, so that's the density of copper. Okay, I don't know if that's clear or not, but we can rewatch the video. I have videos of density on my channels if you want like more detail about this. So let's do something different. Okay, let's say now the density of aluminium is 2.7 by 10 to the cube. Okay, so now it's telling us the volume. No, it says that the volume. Oh yeah, so it's asking us for the volume of 150 grams of aluminium. Okay, so we write down the formula again. We write down density is equal to kilograms per meter cube. We're given that the density is 2.7 by 10 to the 3 is equal to kilograms divided by meter cube. So we have the same problem. Now we have 150 grams and we have to transform that into kilograms. So how do we do that? Well, that's easy. We just come here and we have to do 150 grams. It's 150 grams. We put a 0 here and a comma, 0.15. So now we know that the kilograms is 0.15. Okay, so now we have to find the meters cube. How do we find that? Well, basically what we do is, first, I like to do this in little steps because it's easier. Okay, so this one is dividing, so we can move it here, multiplying. So we do 2.7 by 10 to the 3 meters cube is equal to 0.15, and this one here is multiplying the meters, so it comes here dividing. Okay, so now we do meter cube is equal to 0.15 divided by 2.7 by 10 to the 3. So that's the answer basically. That's the meters cube. Okay, that would be the volume. You put in the calculator. Okay, and that would be the volume. Okay, so that's an easy one. Okay, then it's asking us what is pressure. Basically, the pressure is force per unit area. Okay, which means that if you put a lot of force into a bigger area, there's not going to be a lot of pressure. But if you put like a big force, let's say you stand on the chair with 1 foot, you're putting a lot of weight, a lot of force into one little area, which is your own, like the palm of your foot, then the pressure is going to be greater. Okay, they have videos about this too. Okay, and liquids is different. Okay, I have videos about this, explain everything in detail. Okay, so you can go and watch them if you don't know what it is. So the question is, a force of 900 newtons acts evenly on a surface of area 8 meters square. What is the pressure? So we know that the pressure on objects, the pressure on objects is equal to Fa on solids. Okay, so we know that a force of 900 newtons is an 8 meters square. Area is measured in meters square, so we don't have to transform anything. So now we know that 900 divided by 8 is equal to 112. So the pressure is going to be 112.5, and you can either put newtons per meter square, or pressure is also measured in pascals. Okay, PA. But either of those is correct. I prefer to use pascals because of the actual measurements, but normally they take it correct if you put a newtons per meter square. Okay, so next one will be is something similar. So now we're just given the newtons again, and we're given the area. So we do the exact same. We do P is equal to F divided by A. So P is equal to the force, which is 16 newtons, divided by, actually I'm going to put the newtons because people get confused, divided by 30. Pressure is equal to 2 pascals. And the exact same. Okay, these are easy questions. Okay, again, in any kind of exercise, you have to use the SI units. Okay, they're like the international units. So if area is measured in meter squares and you're given centimeter squares, you have to go up here to the table. So write this down somewhere and transform it. Remember, if it's square, you have to do double the steps. If it's cube, you have to do 3 times the steps, and so on. Okay, so I hope this helped, and I'm gonna put in the description all the link to download the sheet I was using here, plus the rest of the exercises. Okay, so thanks for watching.